ready to blow your mind. Are you ready to have your mind blown? Because what happens if we have 3 ingredients we want to combine? How could you use the alligation method with 3 and then we'll do 4 and then we'll stop because it gets boring after that. So anyways, let's start with 3 ingredients, all right? So in this question it says solve by the alligation, which again, these can be solved using CQ plus CQ plus CQ. So yes, you can do that eventually, but let's practice and still doing our alligation because I still think it works pretty straightforward. In this case, we want to know what volume in milliliters of each ingredient, that being dextrose 10%, 20%, and 50%. So 3 ingredients, 3 concentrations. We want to mix those such that we get 1,000 milliliters. So my target is 1 liter of a 40% concentration. All right, but we have 3 ingredients now. So what's the deal here? The deal is you're going to have to do more than one alligation diagram. But it's important that you always have, with any, because you can only do an alligation diagram with 2. So we're going to have to do multiple 2s, if you will. But we always have to have one concentration higher than the target and one concentration lower than the target. So the way we want you to do this is just kind of mind it out. You don't have to write all this out, but you have to think through this, okay? So what is my target concentration? 40%. What do I want? And then what I'm suggesting to you is to rank all of your concentrations from highest to lowest. All right, so if I want 40, what are my ingredients? I have a 50, a 20, and a 10, going from high to low. And then draw a line and split the concentrations where your target is. So my target concentration is between the 20 and the 50. Would you agree? So I have one concentration higher, which is 50, but I have 2 concentrations lower than the target. So now I have to pick my alligation pairs, and they always are pairs, all right? But I need to use each ingredient. The trick is, though, I can use an ingredient more than once, all right? There's no rule against that. So since I only have 1 higher, I'm going to have my 50% concentration in both pairs. I always have to have a concentration higher. But what I can do is have 1 pair that uses the 20% and the other pair use the 10%. So my 2 alligation diagrams, which you'll see work the same exact way, but I need to set up 2 of them. One with the 50 and the 20, and one with the 50 and the 10. Will we use all 3 ingredients? Will we use the 50%? Absolutely, and the 20 and the 10. So we'll use them all, but each pair has to have 1 higher and 1 lower than the target concentration. So now that we have kind of set up our pairs, let's just do the alligation for them. So the alligation works the same way, but let's just do 1 pair at a time. So don't look at both, let's just look at pair number 1. Do not worry about the right-hand side. So what did we say? Put the high strength on top, so we put the 50% on the top. We put, this pair had a 20%, so 20% on the bottom. Our target is in the middle on the right. So what do? We cross subtract. So going from top down, we go 50 minus 40 gives me 10, not percent. What is it? Parts, 10 parts. Cross subtract. Now let's cross subtract going up. So 40 minus 20 going up that way gives me 20. 40 minus 20 is 20. So I have 20 parts there. And remember, this 20 parts goes with the 50%. This 10 parts goes with the 20%. So far, so good? No different than the alligations we solved before, and once we've set up our pairs, it works the same way. So now we can do the pair on the right and do the same thing, starting with the high 50 on top. The only thing different here is instead of 20, we're mixing it with the 10%. So we've got 10% on the bottom, but to the right and into the middle is still my target of 40%. So cross subtracting down again, 50 minus 40 is 10, so 10 parts going that way. But now going up, I'm gonna get 40 minus 10, which is 30 parts. So that gives me 30 parts. Now this 30 parts still goes with the 50%. This 10 parts goes with the 10%. Now in the end, does 50% have parts from this alligation and this alligation? Did we use it twice? Yes. So we're just going to add the parts together. The parts from the left go with the parts from the right. So in one sense, we have 20 parts from pair 1, 30 parts from pair 2. How many parts of the 50% do we have? 50 total. So the next question is just to summarize all that, is that just make sure you line up all of the parts because there's a lot of ingredients there. So for the 50%, we're saying we had 20 plus 30, so we're saying there's 50 parts of the 50%. We only used the 20% once and it had 10 parts. We only used the 10% once and it had 10 parts. Everyone okay where that came from with what we just did? Now, the only thing new on this slide is, okay, once you've done each individual total parts, sum all of the parts total. So regardless of the ingredient, how many parts total are there? So just add all of those parts up going down. So 50 plus 10 plus 10 gives me 70 parts. And remember, the total parts are going to go with my final desired concentration. So I would argue when I'm having everything mixed together, I'm going to have a total of 70 parts, and I want that concentration to be 40%. So I got a proportion. Now I'm ready for my P's and Q's. What are the only, so let's talk about P's and Q's. I'm going to skip the medial thing. So P's and Q's. I know that for the 40% that I just said my total was 70 parts. And that's the only quantity I know, because I know from the question the only quantity given was the final total mixture amount. So the final Q, the Q for the 40% combination was 1,000 milliliters. So I have that proportion, and with that proportion, 70 over 1,000, I can solve for each individual ingredient. You see what I'm saying? Because each of those equal each other, and they all equal this. So my last step is just to solve for each of these variables by looking at it being equal to the final, which is 70 over 1,000. So if I just show you all that work here, here's my 70 over 1,000, which is the same for each ingredient, right? We said each of those ingredients all have that same equal. And I just put the parts over X, or the variable, solve for the parts for each drug. So 50 times 1,000 divided by 70 gives me 714 milliliters. 10 times 1,000 divided by 70 gives me 143. And since the parts were the same for both the 10 and the 20%, they're going to have the same volume. Now do me a check real quick. Do these add up? What do these add up to? So add up 714 plus 143 plus 143. What should they all add up to? What should all three of my ingredients add up to from a quantity standpoint? 1,000 milliliters. They should all add up to 1,000 milliliters. And when I add those volumes of a 50% and a 20% and a 10% in those ratios and those amounts, well, I'll get 1,000 mils of what concentration of dextrose? 40%. That's where the 40% would be. All right? So really all I had to do was 2 alligation pairs. The only trick is, remember 2 things. Make sure each pair has a concentration higher than the target and a concentration lower than the target, which is why you need to line them all up, make sure you use each ingredient. And remember, if you do use a concentration more than once, then you just add the parts together. It doesn't matter which parts the pair came from or which pair the parts came from, but you add them together for the total. So let's try one more. And again, that was from a liquid version. Let's do the same work for a solid. In this case, we're going to be mixing different concentrations of triamcinolone cream. Have you ever dispensed that? Very common steroid cream that's used for rashes and all sorts of things. So in this case, we want to mix a cream that has 0.1% and a cream that has 0.5%, 0.025%, all right? So those are the weights, okay? And vanishing cream, okay? So I have 3 different concentrations of triamcinolone and vanishing cream all mixed together such that we get what? We get a pound, or 454 grams of a cream that in the end has 0.075% cream. Could you make this cream without all 4 ingredients? Absolutely. As long as you have one concentration higher and one concentration lower, you could mix it. But here, for whatever reason, we want to use all 4 ingredients in such a way that we end up with a pound, or 454 grams of 0.75% cream. Right? So what did we say the first step was? Is to be clear what our target concentration is, and then let's line up each of the concentrations in order from highest to lowest. All right? So remember, my target was this. So then we have to look at each of those concentrations, and I didn't give them to you in order, but if you go in order, the 0.5% is the highest concentration, then 0.1, then 0.025, and then, oh, wait, 0. Where'd the 0% come from? Which of those ingredients had 0%? The vanishing cream, remember, it's a diluent. It's a non-drug containing base. So as far as its concentration of drug in it, it's 0%. There is no drug in vanishing cream. All right? So that's my diluent. All right? So 0% drug there for the vanishing cream. There's my 3 other concentrations from highest to lowest. Now, where does my 0.075 fit? Doesn't it kind of fit in the middle here between those 2? Between those 2 on the left, 2 on the right. So I've got 2 higher and 2 lower. All right? So I will tell you now, there are two correct ways to solve this question. You can match either one of the higher ones with either one of the lower ones, okay? What I chose to do, and for no absolute reason, but realize what I did choose is, okay, here's my first highest. I'm going to put that with my absolutely lowest, okay? So do you see where those two? So I can cross that off and cross that off. Then I'm going to take my 0.1, which is still higher, and my 0.025, which is lower, so I can cross those two off the list. So would you agree, have I used each of my four ingredients? At least once, okay? Do I always have a higher concentration mixed with a lower concentration relative to my desired? Yes. But could I have done 0.0 or 0.5% with 0.025% and done my 0.1% with my 0%? Yes. Do you see where I could have swapped these here? I don't have to match them that way as long as I mix a higher and a lower. Will that change the actual amounts for those ingredients? Yes, but the final answer would be correct. So on an exam, if I were to do this, and I'll tell you now, I'm not going to put this on an exam. When you have four ingredients like this, there is more than one way to answer it. And you will get different numbers that still give you the right final answer. But on a 3 ingredient, there's only ever going to be one either higher or lower. So again, there's only one way to solve a 3 ingredient. So that is definitely possible on the exam, what we just worked through. This one works the same way, but because there are 4 ingredients and multiple ways to solve it, it may not be a great test question. But let's make sure you can answer it. Let's not just worry about the test. So I'm blabbering here, but do you agree we have 2 pairs? And each pair has a concentration higher and a concentration lower. So let's just do what we do with our alligations. So let's start with our first pair, put the higher concentration on top. 0.5 is on top. We said that's matched with the 0%, so that's on the bottom. Our target is still 0.075. So there we have it. So cross subtracting going down, 0.5 minus 0.075 gives me 0.425 parts. Going up, 0.075 minus 0 gives me 0.075 parts. So there's my parts of this concentration. Here's my parts of my 0 concentration. And since they're not reused in the other side, those will be my final amounts for those. Now let's look at pair 2. We said the high was 0.1, the low was 0.025. My desired is still 0.075, so cross subtract carefully. Why are these questions a little bit harder? Are the numbers a little bit longer? Yes, I mean, in less than 0, sometimes people mess up with their decimal points and so forth, so you still need to be careful with your math. But if I take 0.1 minus 0.075, I get 0.025 parts. And 0.075 minus 0.025 gives me 0.05 parts. So these are the parts for the 0.1. These are the parts with the 0.025%. And I'm done. I've got each ingredient and a number of parts for each ingredient. So the only thing I really need to summarize, since really these are just what I just calculated for, I do still need the total of all parts. So if I add all of the parts from each of the 4 ingredients, add them up, I see that the total number of parts is 0.0575 parts, and that corresponds to my target concentration, which is my 0.075. So again, here I have a relationship there. And knowing that I want to make 454 grams of this, my only quantity relates to that concentration. I now know a ratio of 0.575 grams, oh, don't do that, goes with 454 grams. So when I set up my P's over Q's, this is what I know for sure. My target final concentration, its number of parts were 0.575 parts, and I know I want to make 454 grams. That ratio is equal to every other single ingredient parts over Q. And I know the parts, I just don't know the Q. So that means I have 4 of the same formulas to solve. So again, this is what I know is consistent. My parts for my final, 0.575 over the 454. I'll set that equal to whatever parts I need for that ingredient over the quantity of whatever that X quantity is, solve for it, and I can see by solving for the variable for each one of those, I come up with individual weights, which, if I were to add all those weights together, should total what? 454. And when I mix all of those weights of those individual concentrations together, that would give me a 0.075% cream. Okay? So, there's how you can do alligations with more than 2 ingredients. You always do an alligation diagram with 2 ingredients. You can just do multiple ones and they're additive. All right? All right, so that's just watching me do it. So let's see. Now you can choose, okay? I'm giving you your autonomy to choose this question. If you want to use allegation, you can. I had intended you to use algebra just to practice, but you do you. On the test, that will be you. So I love these kinds of questions here. And this is a review, and I'll try to give you a little bit of time to solve this. It says, what is the final concentration of each ingredient? Okay, meaning there's more than one. When 15 grams of benzoyl peroxide, 6% topical gel, so here's a quantity and a concentration of gel, is added to a 45-gram gel that contains two things, adapalene 0.1% and benzoyl peroxide already in it at 2.5%. Okay? So I want you to give me the final concentrations of both the benzoyl peroxide and the adapalene. I will tell you, don't solve them together. When there are multiple drugs, when you're concentrating and diluting, you just do them individually. So just pick one of those. I don't care which one. You can see I'm going to do benzoyl peroxide first, but it doesn't matter. Pick one drug and solve for it. Pick the second drug and solve for it. I like this question because what are we doing with the benzoyl peroxide? We are fortifying it. You'll see that the mass is going to be going up because we're adding benzoyl peroxide to a gel that already contains benzoyl peroxide, so the mass will be higher. But what will happen to the adapalene is we're adding benzoyl peroxide to a concentration of adapalene. That's going to go down. You're going to be diluting that. So you should see benzoyl peroxide concentrations go up, adapalene concentrations go down when you're all done. So this is pretty straightforward. CQ plus CQ equals a final CQ. So let's start. My first question is this original gel. So if we start with the 45 gel here, let's start with benzoyl peroxide. So what is the C and the Q of the benzoyl peroxide in that initial gel? So I'm saying we've got, oh, sorry for that line, 45 grams of the gel, and this gel contains 2.5% benzoyl peroxide, specifically just benzoyl peroxide. So 2.5% concentration in a 45-gram gel. That's what we're starting with. What are we adding to that? We are adding 15 grams of a gel that contains benzoyl peroxide, 6%. Easy enough? So there's the mass of what I'm adding to it. So I have a mass of the drug that I started with. Here's the mass I'm adding to it. What am I going to get in the end? Well, I don't know what my final concentration is. That's what I'm solving for. Did you get the quantity, though? Should be intuitive here. In this case, we know the actual physical quantities. We're adding 15 grams of drug to 45 grams of drug. So clearly my final mixture will have a weight of 60 grams. It's not a variable. It's not an unknown in this specific question. We get 60 grams. So there's the mass of what I get at the end. So let's just set all of those things equal to. So if this is the mass of one plus the mass of the other one, and I'm going to end up with that. So if I do that math, I got basically 112.5 plus 90. That gives me 202.5. Divide that by 60 to cross off 60, and I got 3.375%. And let's just look at that. Does that make sense? Is that somewhere between 2.5 and 6? Because clearly we started with 2.5, we added 6% to it, so it should be a fortification over our low concentration. All right? Now, so what's going to happen with the adapalene? Well, what are we starting with? We're starting with 0.1% and 45 grams. So there's the mass of what's in my cream to begin with. What am I adding to it? I'm adding 15 grams of, there's no adapalene in that benzoyl peroxide gel. So what concentration of drug am I adding with that 15 grams? 0% drug. There's 0% adapalene in 6% benzoyl peroxide. So what is the mass of the drug I'm adding to it? 0. 0 times 15 will be 0. I'm not adding any adapalene. What will I get in the end when I'm done mixing those things? I'll have some unknown concentration of adapalene, but I'll still get 60 grams because 15 plus 45 gives me 60. So I know my final mixture will still be 60 and some unknown concentration of adapalene. So let's set those equal to each other since, again, the drug in the benzoyl peroxide gel, 0. Really, we just have our starting mass equal to our ending mass. So 0.1 times 45 is 4.5 equal to 60x. Divide both sides by 60, and we get 0.075. And that's a percent. And does that make sense? Is that higher or lower than we started with? Lower because we diluted it by adding additional gel that didn't have any drug in it. So the concentration lowered. You okay on that? Seem familiar? All right. It's time for the double D again. Let's do our double dilution. All right. So we can't totally forget about that. And Larry went back and was bad to us again by giving us weird concentrations. So in this question, how many milliliters of concentrated 23% calcium gluconate solution, what volume, what quantity of that 23% concentration solution should be used? That's ultimately what we're solving for, but we want that such that when we prepare 230 mils of a stock solution, and we take 15 mils of that stock solution and dilute it to 480 mils, we get a 1 to 800 concentration. So these are the ones, this is the twos, and this is the three. So we have three things here. So three C's and Q's. So what was the trick for double dilutions? Where do we start? In the beginning or the end? The end. Let's start at the end. Let's start with this information here. And the first thing is this 1 to 800, it's got to go. So I'm hoping you can do this. Can we go from 1 to 800 and say that it's 1 gram over 800 mils? And say if I want a percent concentration, I set that equal to X over 100 mils. This is what you get for a percent. So if I solve for that, I get 0.125 grams. That's 0.125 grams per 100 mils. That's 0.125%. So let's get rid of that number and substitute it with this number. Now I can set up my C's and Q's because I got a Q here and now I got a normal C. So I have 0.125%. That's just 1 to 800. And I've got 480 mils. That's my C3Q3. Okay. What are we using to make that? How do we get that? We're using 15 milliliters of some stock solution I don't know the concentration of, but I know I'm using 15 milliliters of that solution, and my only unknown now is that concentration of that stock solution. So that's X. So that mass of that will be X times 15. So since I know the stock solution makes the final solution, so it's this mass has to equal that mass in the end, I can now solve for X. So if I do that math, 0.125 times 480 is 60, divide both sides by 15, and I get 4%. What does that mean? 4% is what? 4% is the concentration of the stock solution. Yay. I now have C2. Do I have a Q2? I do, because we want to prepare 230 mils. So my C2 is the 4% we just solved for. The Q2 comes straight from the question. That's how much I'm trying to prepare. So now I know everything I need to know about my stock solution. The whole question, though, goes back to what I wanted is the quantity of my concentrated solution. So what is the concentrated solution I'm using? I know it's 23%, all right, but I don't know the quantity. So in that case, and I'm just using Y here, not to confuse it with our previous variable X, so some unknown quantity of this 23% solution. But that's got to equal what I make with my stock solution. So that has to equal that. Now I only have one variable, so 4 times 230 gives me 920. Divide that by 23, and I see that the answer is 40 mils. And it's 40 mils of concentrated stocks, 23% stock solution. When diluted to 230 milliliters, gives me a 4% concentration. And there we have it. So, would you see the C's and the Q's are straightforward, right? They're kind of like what we've been doing here. The only trick is to start at the end because the C3Q3 is the only set where we have both numbers. I always will give you a volume of a final solution and its concentration. So from that, you can work backwards to the stock solution and then ultimately to the initial concentrated solution. All right? That's the only trick to the double D's. All right, here's a straightforward alligation one that, again, you can solve with C's and Q's, but here I'll show you my answer using alligation. It says how many grams of menthol pure drug powder must be added to 50 grams of a 4% menthol cream to get a final 10% concentration. All right, so let's just do it. So what do we have here? The whole trick is when I say pure drug, what concentration do you need to remember? 100%. Pure means 100%. All right, so pure drug, 100% concentration drug, is being added to a 4%, so there's the 4% on the bottom, to make a 10%. So there's my target. I'm going to add 100% drug to a 4% drug, and I want a 10% drug. So once I set those up, and they're all in percents, I can do my cross subtraction thing, going diagonally down. 100 minus 10 gives me 90 parts. Going up, 10 minus 4 gives me 6 parts. All right, 6 parts of pure drug powder, 90 parts of my 4% cream, which means that when I add those two together, I get 96 parts of my final mixture. So I've got parts and quantities and concentrations. So now the only trick is what quantity do I know? And I would argue we only know one quantity, but we do know 50 grams of the 4%. So I have the quantity that goes with those parts. So if I set that proportion up, I know my 90 parts of the 4% cream is going to correspond to 50 grams. And I put my P over my Q. I can set that equal to all of my other parts over quantities and just ask myself, what am I solving for? I want to know how much pure drug powder. So I'm going to do these together. So this is my thing. So all I have to do is cross multiply and divide and solve for X, because X would be the amount of menthol powder, which I know would have a total of 6 parts. So once I do that math and set that formula up, cross multiply 6 times 50, divide that by 90, and I got 3.3 grams. Okay? Is that similar to what was on the quiz a little bit today? But reversed. I think the quiz had a what? A diluent. What is the per concentration of a diluent? A base drug, or a base without any drug in it? 0%. 0% for a diluent like vanishing cream that we've talked about, or 100% for a pure drug. All right, last one, because I'm running out of time here, but let's see, I do have some time. All right, same sort of thing here. And again, I'll show you my work using an alligation, but you can do this with C's and Q's and algebra as well. What volume in milliliters of this injectable solution, dexamethasone 4 milligrams per mil, should be added to a 15 ml bottle containing 0.1%, such that we get a final combination that has a concentration of 0.3%. So ultimately, I want 0.3%, which I'm going to get by starting with 0.1% and adding additional drug till I get my higher 0.3% concentration. So here's a percent, that is not a percent. That's a problem. So the first thing let's do is let's convert that 4 milligrams per mil to a percent concentration. All right? So hopefully you're good at this. 4 milligrams per mil. Let's get rid of the milligrams by dividing by 1,000. That would give me grams per milliliter. And why do I want grams per milliliter? Because percent weight per volume is grams per 100 milliliters. So if I put 0.004 grams per mil equal to X over 100 mils, that will proportion it out to tell me that I would be equivalent to 0.4 grams per 100 mils. That's equivalent to 0.4% weight per volume. So this concentration is equal to this concentration. Now let's use this. So essentially, I'm going to be using a 0.4 and a 0.1 to make a 0.3%. That's what I'm trying to do. So let's set up that alligation. 0.4 concentration on high, 0.1 concentration low, target concentration in the middle on the right, 0.3. Cost subtract going down, 0.4 minus 0.3 is 0.1 parts. Point going up, 0.3 minus 0.1 is 0.2 parts. 0.2 parts go with the 0.4%, 0.1 parts go with the 0.1%. Add those up together and we get 0.3 parts total for the 0.3% ingredient. Now let's look, what quantity do I have? I have a 15 ml bottle of a 0.1%. So these two go together. So the 15 mils goes down here with the 0.1 parts. So let's set up that proportion. Basically 0.1 parts for every 15 milliliters of the 0.1%. Now I can set my parts over the unknown Q's all equal to that. And what am I solving for? Volume of this. So this is what I want. So let's match those two up together and just cross multiply and divide. So 15 times 0.2 divided by 0.1. I show that work here, gives us 30 milliliters. So that means we're going to take 30 milliliters of this injectable, add it to the 15 milliliter bottles, mix it all up, and we will have a final concentration of 0.3%. And our final volume would be the 15 mils plus the 30 mils. We'd have 45 mils total.